Hi and welcome to this video for the BTEC Applied Science Level 3. It's Unit 2, Assignment 3 that we'll be looking at today. So this is paper chromatography. So you'll be doing two practicals within it, one paper and one thin layer chromatography. The general gist of them are the same, and that what you'll be given are some standards and you'll be given one unknown mixture. And the aim of it is to figure out what is in the unknown mixture. So it'll be two of the three or four standards that you are given, and yeah, just basically need to work out the RF values and figure out what they are. So in this practical, as we can see, we are dealing with three amino acids, leucine, methionine, and aspartic acid, and we'll be given an unknown mixture that's got one or two of these three within them, and to figure out which they are. So you would carry out the practical. You should have done a practice one of this, and there's plenty of videos on the internet showing you it if you need to visually see it. But general gist of it, as you can see here, you'd have your standards dotted along. So leucine, methionine, aspartic acid, and then the unknown. Dip them in the solvent. Your solvent should not be above that starting line there. So remember to obviously have a pencil line with where they are starting. You have the lid on just to get a saturated atmosphere in here. And you let the solvent run up. So the solvent is the mobile phase. It will drag up the chemicals at different speeds depending upon their interaction with it. Remember to record where it finishes at. So a lot of students forget that. You should record the end line where the solvent gets up to. And then what you would need to do with a paper chromatography, like it says, we need to spray with a, where is it? Might be a little bit down. Ah, yeah, so they're spraying with an anhydrine just to show the actual color. So you won't see the amino acids until it's been sprayed and heated up. Avoid touching it with your fingers, otherwise the amino acids on your skin will stain it and you'll probably have to repeat the practical. So just to give you an idea of what it should look like, here is a picture of it. So hopefully clear enough for you to see. Got the leucine, methionine, aspartic acid, and the mixture there. So we can see where we've started them off. 1, 2, 3, and then the unknown on the side there. I've got the top point of it, so I know where I've started here, and I know where the solvent has ran up to there, clearly marked. So we need to work out the RF values. It's fairly obvious by eye which two amino acids are actually in this mixture. As we can see, we've got dots that are pretty much at the same height there, and likewise at the same height here. But you need to be able to show the calculations just to be safe. So RF, we should be able to work out. It's the distance traveled by the sample over the distance traveled by the solvent. So you just need to get a ruler for this. So I'm just going to make up some rough numbers, just since I'm looking at this on a Word document. I'm just going to say this traveled exactly 5 centimeters, just for the ease of it. Now, for these, as we can see, they are not nice, neat dots. They are actually fairly big smears. Generally, the better it's done. So what you want is kind of a few concentrated dots put on this point. But you don't want to hold that glass pipette that you're probably using, the little teat pipette, on there too long. Otherwise, if you end up with a big blob of your sample, it will smear out a bit like this. Generally, you want to go tap, tap, tap on there a few times so it's concentrated but at a sharp point, and that'll give you smaller dots on this. But it doesn't matter as long as we can clearly see them. So what I would do is I would record the bottom of that and the top of that with where they've got up to. So I'm going to say roughly, I'll just make up some numbers, We'll say that's 3.2 centimeters, and we'll say 4.6 centimeters up there. So I want to know where the middle is. So distance between them, as we can see, 1.4 centimeters, halfway between 0.7, so 3.2 plus 0.7 means that middle is at 3.9 centimeters. So to work out the RF then for leucine, I do 3.9 divided by 5, and that gets me 0.78. Now, RF values should always be between 0 and 1. They cannot go above 1. Otherwise, what it means is you've got a dot somewhere up here that has somehow jumped past the solvent. So anything above 1 is wrong. Chances are what you've probably done is put these numbers in the wrong way around. So the bigger number, the solvent, should always be on the bottom. And as we can see, all of the samples have traveled less than the solvent. Smaller number should be on top. So you would repeat this for all of the others. So again, I'd work out where the middle is there. I'd work out where the middle is here. Like that. So I'm just going to make some numbers up. So leucine, methionine, aspartic acid. So I'll say 0.78. Looks a bit lower for methionine. So we'll say 0.50. And aspartic acid, the lowest down. So we'll say 0.23 for that. But again, you should obviously be working these out with a ruler. Show your calculations for it, otherwise you will not get as much credit. And then for the unknowns, so the mixture, we can see we've got one which probably looks to be about 0.24, just tiny bit above the aspartic acid. And then likewise for the leucine one, 0.79. So what I would say here is the two amino acids present in the mixture, leucine and aspartic acid. And when you're explaining why, you just simply quote these numbers. So that is the closest option we've got there. And likewise, the closest option we've got there for that. If they're exactly the same, brilliant. Means you've done the practical really well. Generally, they'll be within a little bit of each other, just based upon, maybe you've had the paper a bit slanted or something like that. But as we can see, pretty much exactly the same. And that is it for chromatography. Generally, the thin layout will be exactly the same, where you'll just be using the silica-based rather than the paper-based for running materials up it, and simply calculating RF values, distance of sample over distance by solvent, and for the unknowns, you just find out which of your standards are the closest to your unknowns, and that tells you what was in there. So it's quite a useful analytical technique for any sort of blood samples, things like that. They tend not to use paper chromatography, but it's instruments that work on the same principle. Thank you.